the time for delegates' presentations. I understand from Dr. Hasrat that we have one delegate that announced his or her missing. But I now invite Mr. Shubham Singh to take the floor and present the information prepared for this technical session. So, Mr. Shubham Singh.
Yes, ma'am. Am I audible, ma'am?
Yes, thank you. You've just shared your screen. Just to make it full screen, please. Thank you.
Can I start, ma'am?
Yes, please. Yes, you are full screen now. Thank you. You have 10 minutes, as you might already know.
Okay.
Thank you.
Respected chairs, co-chairs, delegate participants, and learner participants, good evening to one and all present here. I'm going to draw your attention towards my work on the soil indices and nutrient management through Azolla integration in soils of. So, moving further towards the topic, I want to draw your attention towards this topic. When we first came in our mind that there is a lot of work in this nitrogen and Azolla thing. So here from my work, I want mainly on the soil acidity problems, mainly phosphorus needs reduction by Azolla. So we know that is one of the major constraint in crop production throughout the world. It affects around 3.95 billion hectare area. In India, 1/3 of the land affected by soil acidity. So soil acidity influence the chemical and biological reactions that control the plant nutrient availability and toxicity of the some elements. And it also have a constraint in the crop productivity. So it's very important and a need of the hour to manage the soil acidity and go for the crop productivity improvement. Moreover, we also know that for improving the soil acidity, we are using liming. So that is also it's not economic. It's very expensive. So we can go for any alternative like Azolla, which have a very high nitrogen fixing. In soil acidity, there are several indices which is used to correct the soil acidity for the maximizing of the crop yield. These indices include pH, acidity saturations, and a lot more. So keeping in this consideration, I determined two mainly to study the effect of nitrogen and phosphorus through urea and the yield of rice and also on the soil acidity indices. I formulated 6 treatments with with soil application of urea and the rest treatment with Azolla. So when we look on the first table on the effect of the on the yield, we found out that grain yield differs significantly among the treatments. There are around 17% increase in the grain yield when we compared T5 treatments with the T3, and also there is a significant increase when we compare with the T6 and T4. If we look in the nitrogen concentration, here also we can find that there is a 22% increase in the T6 where it is a integrated treatments of Azolla and urea when it compared to the control. It is mainly because of the improved plant health and accelerating plant growth processes, and also by the application of the nutrient through organic sources. For Azolla, it had better availability to nitrogen due to narrow CN ratio, which help in the mineralization of the nitrogen, and it enhances activity of the microbes which play a role in the of the nutrient cycling to a better uptake of the plant. Release organic acid. If we look in concentration, Here also there is a 53% increase in the straw concentration, phosphorus concentration in the straw when we compare T6 integrated treatment over the control. Here also the reason, most probably the reason will be the organic matter forming the chelate with aluminum and iron in acid, which result in the low phosphorus fixing capacity. And also it is due to the synergistic effect of the nitrogen and phosphorus. And the production of organic acid during decomposition also helps in this mineralization of the phosphorus. If we look for the potential, the results mainly for grain and straw is not significant, but for the uptake, there is a significant results when we compared it with the T6 and T5, means the integrated treatments of urea and azolla with the control. It's due to the good proliferation of the root system resulted in the better absorption of the K, and also it is due to the priming effect. Priming effect is that when azolla on decomposition, it releases organic acid, which solubilizes the native and fixed and non-exchangeable form of K, which on the later stage will available to the crop growth. So here, if we see the effect on the organic, here we can see the which is the T6 treatment have better and organic carbon percentage with the time available when we see on the 30, 60, 90 and at maturity over the. And here the mainly the effect of urea soil acidity indices, and here we can see that treated plot have more organic carbon because of more biomass, and also in combination with the urea, which enhance root growth, leading to accumulation of the more organic residue in the soil. For pH, we can see that it is a non-significant, but then also slight increase in the pH as compared to initial value. Initial pH was around 5.12. So decrease in the pH of urea plot, it's due to the acidic residual nature. And if we see for the exchangeable aluminum and exchangeable acidity, we see that in T2 treatments, which is the sole application treatment of the urea, has lowest as compared to the other treatment. It's because of the proton consuming ability of the humic materials and have reduced acidity in this case. So this reduction explained by the steady formation of the organic materials with functional groups such as carboxylic and phenolic group during decomposition and low solubility of the calcium carbonate. Similarly, exchangeable calcium magnesium also, we can see that azolla have values due to the higher concentration of the organic matter in this result in the high biomass, and it is same as CEC. So at last I conclude that the combined application of the with nitrogen significantly increase the grain straw yield over the sole applications, and integration of with urea was found most appropriate production of the paddy in acidic soil. Therefore, the combination in acidic soil for paddy production, it is recommended to farmers. Thank you, and I conclude my presentation here.
Thank you for sharing with us